Hello everybody, welcome. So today we are going to be watching the Double Asteroid Redirection Test. Not the actual redirection test, but the launch of the spacecraft aboard SpaceX's Falcon 9 rocket. Putting together the final pieces here for the tweet about this live stream. Always gotta do the tweet and the announcement. Alright, so what the heck is happening tonight? Well, in 27 minutes, SpaceX is launching NASA's Double Asteroid Redirection Test aboard the Falcon 9 rocket from Vandenberg. NASA's Double Asteroid Redirection Test. NASA's going to attempt the very first planetary defense mission. So this is basically a test to see, okay, if we hit an asteroid with a spacecraft, what happens to it? How much can we affect it? How much of the momentum from the spacecraft is imparted to the asteroid? Can we change its orbit? These are all the things it's going to test. It is launching today, and it will be intercepting the asteroid in about 11 months. I'm going to switch over to the live stream.
Pacific time, so if you are watching from the East Coast, it's going to be already early the next morning. And there's a special reason why SpaceX fuels this close to liftoff.
Yeah, and that's because they use densified propellants, which are very, very cold. And so they fuel this close because they don't want it to warm up too much, and you want to keep it down in those really cold cryogenic temperatures prior to liftoff. And SpaceX has gotten very good at that, at fueling this late in the game. They're very efficient at it, and it's just a normal part of the process at this point.
All right, so we're going to continue to keep an ear on things. Next thing we'll be listening for is the SpaceX launch conductor poll at T-minus 4 minutes. That's the next milestone you see on that progress bar on the bottom of your screen. So we'll be listening in for that. And for now, we're going to toss it back over to Daryl and Kelly.
All right, thank you very much, Marie and Denton. And now we want to get back to the science of this mission and talk a little bit about the what if, Kelly. You know, this is a big deal. A lot of people probably haven't heard of this. Like, oh, wait a second, should I be worried about, asteroids now? But it really comes down to all the documenting and cataloging that you guys are doing. So how many asteroids are out there?
Right, well, NASA-funded telescopes are responsible for most of the near-Earth asteroid discoveries, which now number 27,532, according to the Center for Near-Earth Object Studies website.
So if anyone has any questions, feel free to ask. I'm basically just going to follow along, give my comments as I feel the need to. We are about just under 25 minutes from liftoff here. And yeah, feel free to ask anything. Done my reading. Got some animations and stuff, so I can explain things if anyone wants.
Keep our eyes to the skies and eventually get a telescope up there, right, to look at this.
Right. NASA funds these ground-based telescopes that search for near-Earth asteroids, and they're doing a fabulous job, but it is also developing the Near-Earth Object Surveyor mission, which will be a space-based infrared telescope really designed to do this type of survey work and accelerate the rate of discoveries of near-Earth asteroids.
Great. Space-based telescope specifically purposed for looking for asteroids.
Right.
Looking forward to that mission. And so what if there wasn't enough time, though, to knock it off course? Well, earlier, NASA's Raquel Villanueva talked to two key people about how FEMA and NASA are working together on this.
While there's currently no threat of an asteroid or comet heading toward Earth, there is plenty of work being done to prepare for a potential threat. I'm here today with NASA Planetary Defense Officer Lindley Johnson and Leviticus Lewis with FEMA to talk about some of the measures being taken. Leviticus, Lindley, thank you for joining us today.
Glad to be here. Yeah, you're welcome.
Now, how do your agencies work together when it comes to planetary defense?
Well, we at NASA are tasked with trying to find any impact threat that might be out there, any asteroid or comet that is close enough to Earth that it could impact us, and then be able to determine when and where that impact might occur so that we can inform the emergency response community if we don't have enough time to do something about it in space.
FEMA is the Federal Interagency Coordinator and also an all-hazards organization. So planetary defense is just one more thing on our list of hazards that we should be prepared for.
One of the many emergencies. Now, Lindley, if there were to be an asteroid that posed a threat to Earth, what is being done to discover and track this?
Well, NASA and the Planetary Defense Coordination Office sponsors projects around the country at observatories and universities, space institutes that are searching the skies every night to find any asteroid or comet that could be an impact threat to the Earth in the future. We want to find them far enough in the future that we have a chance to do something about them, like use DART to deflect them off of that impact trajectory. But if the time is short and we're not able to do that, then an asteroid impact is just like any other natural disaster, and so the emergency response community needs to know when and where and what the effects could be.
And if an asteroid posed a significant threat, what steps would be taken next?
Well, we collect as much information as we can about the asteroid through the remote observing and determining the composition and size. It might be small enough that Earth's atmosphere would disintegrate it, but if not, then there could be damage at the surface. We want to be able to appraise the emergency response community how extensive those effects might be, what kind of area might be impacted by this natural disaster.
And Leviticus, how would FEMA work with NASA if this type of scenario were to happen?
So we're not going to be changing our procedures exactly, but we want to make sure we account for the differences in the science and then in this particular scenario. So it'll be another emergency added to the list of things we handle every day.
Leviticus, Lindy, thank you so much for your time.
You're quite welcome.
You're welcome.
All right, DART is the first time we've ever used a spacecraft as a kinetic impactor into an asteroid. So we asked the astronauts on board the space station to demonstrate what a kinetic impact looks like in space.
Hi everyone, I'm Thomas Pesquet and I'm with my favorite astronaut, Shane Kimbrough, up here on the space station. Today we're going to talk about a very cool new NASA mission. It's called DART. Can you tell us and tell me a little bit more about what is NASA's DART mission?
Okay, yeah, so DART is NASA's first planetary defense test. So we're gonna try to do something we've never done before with a spacecraft. And now the purpose of this spacecraft and this mission, it has one purpose, and that's to crash itself into an asteroid and try to redirect it or try to move it into a different orbit.
So today, Shane, we're gonna demonstrate some of those principles that you laid out before. But can you tell us exactly how we're gonna do that?
We're going to try to demonstrate this asteroid kinetic deflection method, which is really the moment that spacecraft crashes into the asteroid. So here we go. On purpose.
Shane is going to be the asteroid, and I'm going to be the NASA DART mission. I'm going to try to throw this CTB, and we'll look at the effect of that mass coming at him and the kinetic.
This is going to be exceptionally silly. I'm looking forward to
perfectly
this.
stable. You ready? All right, here it comes.
Awesome.
I've redirected Shane successfully. Pretty good. A while ago, we got out the door and we got some new solar arrays here on the space station.
And so the same technology we have here now on the space station is going to be used to power the DART mission on its way to this asteroid.
ROSA, in case you didn't know, but you knew, it stands for ISS Rollout Solar Arrays.
So we got a chance to go outside and install.
So I want to talk a little bit about the technology development that's going to go on here. So there's a whole bunch of stuff beyond the fact that we're going to smack an asteroid. There's a lot of things about this mission that are interesting. There's a whole bunch of technology demonstrations going on with this mission. First one I'm going to talk about, since we have a little bit of it on the screen here, is DART will use rollout solar arrays. So these are basically tucked away, all rolled up against the spacecraft's body, and they unfurl and roll out when they're deployed. Very different from traditional solar arrays, but could really help cut down on cost and also save space and weight when launching spacecraft. As they showed, the International Space Station now has a whole bunch of these rollout solar arrays deployed aboard. And they're doing a lot of the work now to power the ISS. Additionally, for this DART mission, it'd be the first time that a smaller spacecraft uses the rollout solar arrays. Additionally, there is the Next C ion engine that NASA developed. It is basically the next generation of ion engines. It is significantly more powerful than its predecessors. And it will not be the main propulsion for DART, but it is on board, and they will be doing propulsion tests with Next. Next C is now a commercial product. NASA did all the development for it, and it can now be sold to any company, so any company can buy it and use it on their spacecraft. On top of those two things, there is a portion of one solar panel that has another little section that is different. It's called a transformative solar array, and what these are trying to demonstrate the viability of a solar collector array rather than the traditional just flat panel solar arrays. So this one would have mirrors that redirect the sun into a more powerful solar array. They're hoping that they can basically improve the efficiency of solar arrays make it easier to use them for deep space missions, because you can generate more power from a given size of array. There are a couple other things as well. One of them is that there's an Italian CubeSat aboard this mission, which is pretty cool. It's going to deploy shortly before the DART spacecraft impacts Dimorphos. And the CubeSat will basically take pictures of the impact and if it can, the resultant crater, and ejecta, so anything that gets knocked off of the asteroid. Unsurprisingly, at this point, we're actually not really sure what's going to happen when we hit the asteroid. We are learning a lot in recent years about the makeup of asteroids, but part of what we're learning is that a lot of them are just rubble piles. By rubble pile, what I mean is they're not like a solid rock, but they are a collection of gravitationally bound together rocks, basically. Just a whole bunch of rocks that are stuck together by gravity. So if this asteroid is a rubble pile, it's possible that there will be a much bigger impact from DART hitting it than if it's a solid mass. So this should be very interesting. Yeah, let's go back to the stream.
Administrator Thomas Zurbuchen to talk about what DART means to the agency. Thank you so much for joining us today, Thomas.
Good to be here.
Yes, exciting. Now, can you tell us about DART as NASA's first planetary defense test mission and how this mission will change how we explore space?
So first of all, everybody should be sure to know that this is not the first. Not only the first and only mission, but really the first of many missions that we're going to do in planet defense. The second one we're already working on, which is to find the other 60% of threatening bodies. What's also exciting, though, is that this mission carries technologies we're going to use for exploration of the outer solar system, perhaps sample returns to comets, asteroids, or visiting the moons out there, the amazing worlds that are there.
And that kind of brings me to my second question. How is DART different from other NASA asteroid missions like Lucy or OSIRIS-REx?
So first and foremost, we're not crashing those at all, and certainly not intentionally, and actually no chance of that. Look, the other asteroid missions are all about learning from these asteroids about our history, the history of the solar system. These primordial bodies out there tell us about the building blocks of the solar system, and we still have a lot to learn. So asteroids are really exciting. They tell us a part of our own history.
And after DART launches, what other missions are you looking forward to in the future?
Wow, before the end of the year, we have 2 astrophysics missions. A small one focused on X-rays, the violent universe, kind of black holes and exploding stars. And then the biggest mission we've ever done, the James Webb Space Telescope, mission in the making for 20 plus years and part of dreams of thousands, if not 10,000s of astrophysicists worldwide. That's still before the end of the year, and many more next year.
It's a busy end of year ahead. Thank you so much for joining us, Thomas.
Thanks to you.
Well, thank you, Sarah.
Back to you, Daryl.
All right, thank you both for that. And back inside the NASA hangar here. But by the way, that's the little box that DART came in. I just want to point that out.
It takes to land the first day.
That's awesome.
I mean, this is where we keep the box for DART. But we don't want DART to come back into the box.
No.
We want to go to space. Hey, talking about your office, the Planetary Defense Coordination Office, you got the little patch there. In fact, I was observing a little Latin phrase that at the bottom. What does that say?
Hic servare diem, which means here to save the day. So.
Here to save the day.
Winds are good. We don't expect to have any weather holds for launch. The weather conditions also look good for booster landing on our drone ship and for fairing recovery in the Pacific Ocean. So with that, the launch vehicle, the spacecraft, the weather, and the range are all good to go for a 10:21 p.m. Pacific time liftoff from Space Launch Complex 4 East.
Liftoff of Falcon 9 will kick off a roughly 11-month journey for the DART payload. The DART spacecraft will separate right around 56 minutes into flight, and from there it will spend the next 11 months cruising to its intended destination, intercepting the binary asteroid system between late September and early October of 2022. DART's target asteroid is the size of 2 football fields. Impact will occur when the distance between Earth and the asteroid is near its minimum, within 6.8 million miles or 11 million kilometers of Earth. This will enable scientists to observe and measure the change in momentum of the Dimorphos asteroid. And it's worth noting that Dimorphos is not a threat to Earth. Therefore, it's a perfect testing ground to see if intentionally crashing a spacecraft into an asteroid is an effective way to change its course should an Earth-threatening asteroid be discovered in the future.
Now, the DART demonstration has been carefully designed with 4 key objectives. The first objective is to demonstrate a kinetic impact with Dimorphos, the smaller the 2 asteroids. DART will hit the asteroid nearly head-on, delivering enough energy to leave an impact crater, but not enough to destroy the asteroid.
All right, just give me a moment here. I'm gonna switch over to the SpaceX stream. Sorry, that's what I was trying to do, and I didn't realize that I was blinding you. There we go, that's much better.
The DART demonstration has been carefully designed with 4 key objectives. The first objective is to demonstrate a kinetic impact with Dimorphos, the smaller the 2 asteroids. DART will hit the asteroid nearly head-on, delivering enough energy to leave an impact crater, but not enough to destroy the asteroid, eject it from its orbit around that larger asteroid, or noticeably change the pair's orbit about the Sun. Now, the second objective is to change the binary orbital period of Dimorphos. Now, the orbital period is the time it takes the smaller asteroid to circle the larger asteroid you can see here in the graphic. Currently, Dimorphos is in that original orbit. Scientists estimate the collision will shorten the smaller asteroid's orbital period by several minutes, placing it into that new blue orbit. Now, the third objective is to use ground-based telescope observations to measure the orbital period change before and after the impact. Telescopic observations in the weeks after impact will confirm that DART changed that orbital period of Dimorphos, and it'll reveal by how much. And then finally, the fourth objective is to measure the effects of the impact and the efficiency of that deflection. Now, choosing this binary asteroid target for the demonstration takes advantage of the fact that changes in that smaller asteroid's orbit around its larger partner can be more easily measured than the changes in a single asteroid's orbit around the Sun.
To ensure the best possible data capture, the DART mission is taking along some pretty cool technologies to help capture this demonstration test. On board the spacecraft is the Didymos Reconnaissance and Asteroid Camera for Optical Navigation, also known as DRACO. Now, this is not to be confused with the Draco thrusters on SpaceX's Dragon spacecraft. DART's DRACO will provide real-time streaming images of the asteroid as it approaches impact. In addition to the onboard camera, the team is also flying a CubeSat from the Italian space agency known as LICIACube, which stands for Light Italian CubeSat for Imaging of Asteroids. This cube will be deployed from the DART spacecraft 10 days prior to impact with the asteroid. LICIACube will use its onboard propulsion system to alter its trajectory, offsetting so that it flies past Dimorphos approximately 3 minutes after the DART impact to capture the effects of the impact. Now, it's pretty incredible to think about what a mission like this could mean for the future of planetary defense. Now let's take a closer look at what the NASA team is hoping to achieve with the Double Asteroid Redirection Test mission.
In case there was an asteroid coming towards Earth and you're there, you can actually stop it. I mean, that's kind of fantastic.
NASA is crashing a spacecraft into an asteroid.
What? You think science fiction, but this is real. Never in my life would I have thought I would take a couple $100 million spacecraft and crash it into an asteroid. My name is Michelle Chen.
I'm Lena Adams. My name is Kelly Fast.
I'm Andy Rifkin.
I'm Justina Sorovitz, and I help tell the story of the DART mission.
I'm a planetary defender.
And I study how the orbits of asteroids change after we hit them with spacecraft.
My job was primarily to make sure all the systems on the spacecraft work together.
The DART mission is NASA's first test of a planetary defense technique called Kinetic impactor.
DART is the Double Asteroid Redirection Test.
It's just a spacecraft that is going to go and smack an asteroid.
The moonlit Dimorphos, which orbits the asteroid Didymos.
And see if we can change its trajectory just a little bit.
In order to show that we can deflect incoming asteroids if we need to.
DART will only be changing the period of the orbit of Dimorphos by a tiny amount.
But in space, just a little bit is just enough to make an asteroid actually miss us.
In the event that an asteroid is discovered well ahead of time before it might impact Earth.
Behind me, you see the spacecraft.
It's really cool to see it coming together in real life.
It is fantastic to see it in real life.
To see it turn from ideas into real pieces that are going to go into space.
The solar arrays will actually roll out to 28 feet in length.
Once the solar arrays are deployed, it's going to be the size of a school bus. As the solar array opens out, it's going to swing out in this direction. The asteroid's only 2 football fields in size.
We're flying at over 6 kilometers a second.
30 days out, we see 1 pixel on our field of view.
You can see Didymos and Dimorphos as 1 point of light.
About 4 hours out, our spacecraft becomes autonomous.
And then that's where everything gets really exciting.
You actually are seeing impact.
We're super excited and nervous as well.
I feel really honored and humbled to be working in an area of science that has such a broader impact, figuratively and literally.
No DART. The dinosaurs are made completely extinct by an asteroid impact so many years ago. Here we are, we can actually do something about it. I think this is just wonderful.
It's currently T-minus 4 minutes and counting. Everything continues to be go for launch. Spacecraft is transferred to internal power.
Hey Sargrath. So how did the solar rails stay rigid? Basically they're telescopic is my understanding, and then they pull out the rolled up solar film into basically like a rigid shape. So they're like metal telescopic rods that go out from the spacecraft. Pretty cool. Yeah, I'm really looking forward to seeing what they have to say about the deployment of the solar arrays. Sorry, I'm a little tired. It's kind of late here, but wow, I always love watching Falcon 9 breathing before it lifts off. Huge plumes of mist around it.
LOX load complete. That is the first stage LOX loading being completed. Second stage will complete.
Gonna be really something when this is Starship, because it's so much bigger. It's gonna be a whole thing. Starship has had a bunch of really big steps forward recently too, so we should see it launching in the next few months here. And that's going to be a whole other thing.
Now, as a reminder, we do have, if we do have a hold on today's launch for any reason, we do have a backup opportunity tomorrow with a liftoff time of 10:20 p.m. Pacific time, just a minute earlier than tonight.
Coming up on T-minus 2 minutes, waiting for the call out that LOX load is in closeout.
Stage 2 LOX load complete.
There we go. Stage 2 LOX load is complete. This completes loading of the over 1.1 million pounds propellants on the Falcon 9. All systems remain go for launch.
Wow, that is cool.
Now the SpaceX ground computers are now draining propellant out of the lines that go up the strongback to the second stage. And that creates the white cloud that you see around the strongback.
We'll never get tired of watching these
Pressure
missions.
from the ultra-cold liquid oxygen line is being vented, and that causes moisture in the California night air to condense. Next event will be the startup call-out at T-minus 1 minute. The first second stage computers on Falcon 9 will execute programs to prepare the rocket for flight, leading to ignition of the Merlin engines at T-minus 2 seconds and liftoff at T0.
Falcon 9's in startup.
There's that call out. Falcon 9 computers are now running the final sequence for launch. First and second stage tanks are beginning to final pressurized for launch. Just waiting for
Dart, go for launch.
And there's that final go for launch with all systems.
Dart
go
is
14-0.
go for
Let's listen into the
launch.
terminal count and watch Falcon 9 transport NASA's DART spacecraft into orbit.
T-minus 15.
10,
9,
9, 8, 7, 6, 5, 4, 3, 2, 1,
0.
0.
On the way for humanity's first ever planetary defense test mission.
Here she goes. Wow, we were way behind the stream. My God. Oh, I love that IR footage. The infrared footage.
T plus 33 seconds. SpaceX launch engineers seeing a nominal conditions on Falcon 9 as we begin the trip to space carrying the DART spacecraft. M1D engines about to begin throttling down.
Power and telemetry nominal.
Oh, that's such a cool shot.
We're throttled down.
Oh, look at that.
Avionics calls out good power on the vehicle.
Vehicle supersonic.
Max Q. There goes Max Q. Oh, wow, that was cool.
Max Q.
We've gone supersonic. We're through the period of maximum dynamic pressure. And the Maryland 1D engines have throttled back up to full power. We're out of the throttle bucket. From here on, even though the velocity is rapidly increasing, the atmospheric density is decreasing, and so the loads are decreasing now on the Falcon 9. Everything continues to look good with the stage 1 trajectory.
Invec chill has started.
Lead valve is open on the second stage engine. That's beginning the final chill prior to second stage engine ignition. 2 minutes into flight. All continues to go well. In 30 seconds, we'll have three significant events coming up in quick succession.
Here in about
we'll get
15
MECO,
seconds.
main engine cutoff, where we shut down the 9 Merlin engines. The stages will separate, and we'll get ignition of the MVAC-D second stage engine to power DART and the second stage into their parking orbit.
Just a few more seconds here. You can see that engine plume expanding.
We've throttled down to hold at 4 Gs, getting ready for MECO.
Holding at 4 Gs.
MECO.
MECO.
Stage separation confirmed.
Beautiful. Good stage separation. And there goes the upper stage. Boop.
Invec ignition.
We've got successful stage separation. Second stage engine ignition now at full power on the Merlin engine. Next event coming up is going to be payload fairing jettison. On the left side, you can see the titanium grid fins on the first stage beginning to deploy as we get ready to bring the first stage back down to the drone ship, Of Course I Still Love You, in the Pacific Ocean.
It's a good note.
Getting ready
of
now,
course,
there's
I
the view
Separation confirmed.
of the fairing.
Oh, beauty. There goes the fairing separation. Lovely. That's a good note. Of Course I Still Love You is now in the Pacific Ocean. It moved from Florida to Los Angeles. So the rocket will be landing on Of Course I Still Love You.
Stage 2 on nominal trajectory.
Everything going well with Falcon 9 and DART.
What you're looking at on your screen is a live view of that MVAC engine on our second stage, burning bright. We are currently in the first of 2 planned MVAC burns for spacecraft deployment today. At T plus 6 minutes and 40 seconds, you should see on your screen, hopefully we'll get some live views of the first stage entry burn. And that entry burn will last about 30 seconds. Now, for the entry burn, we relight the center E9 engine, and then partway through, we relight the E1 and E5 engines, so that we have 3 total M1D engines helping to slow the vehicle down as it passes back into the Earth's atmosphere. And again, what you're looking at on your screen is the MVAC engine on the second stage. We're getting some awesome live views. And everything is still looking nominal for stage 2.
Looking very good. You can see the on the progress tracker there at the bottom of the stream that the entry burn is coming up in a
At
minute
T
or so.
plus 5 minutes into this mission, we're just under 2 minutes away from the entry burn on the first stage, as second stage is continuing on its journey. Again, this is the first of 2 planned MVAC burns for this mission. Now, the Falcon 9 booster supporting today's mission will perform this entry burn for the 3rd time because it's previously supported a Starlink mission earlier this year and the
Stage 2 on nominal trajectory.
Just to call out that stage 2 is looking nominal, which is great news. The first stage booster, again, supported a Starlink mission earlier this year and the Sentinel-6A mission in November of 2020. Now, both fairing halves for this mission are brand new and will be recovered for the first time on a recovery vessel, NRC Quest.
Excellent. NRC Quest is getting some work there.
And we are just about 30 seconds away from that entry burn on first stage.
Sorry for not answering before, Sargrath. They still do have 2 drone ships in the Atlantic. A Shorefall of Gravitas is the brand new one. It looks a little different from the other ones. It's pretty sexy, actually. And the other one is the Old Faithful Just Read the Instructions.
Stage 1, FTS is saved.
You'll see entry burn is starting now.
Stage 1, entry burn startup.
And we heard the call out as well as visual confirmation that the entry burn has begun on the first stage. Again, this is about a 30-second burn and just helps to slow the vehicle down as it's re-entering the denser part of the Earth's atmosphere.
Stage 1, entry burn shut down.
And as you could see, the engine shut down on your screen. We did hear a call out that entry burn is complete.
Excellent. Stage 2, FTS is saved.
Stage 2 continues on a nominal
trajectory.
trajectory.
1 here coming up in about 25-30 seconds.
Now coming up in
Terminal guidance.
Just a little over a minute will be SECO 1. That is second stage engine cutoff 1. Again, there's 2 burns for the MVAC engine on the second stage, so we are in the first burn.
Expected loss of signal code.
So we should see this engine shut off here shortly. And about 20 seconds later, we'll see or hear the landing burn call out on first stage begin.
And
MVAC
SECO 1.
shutdown.
Good shutdown of Merlin 1D. And landing should be coming up any moment now on the drone ship. So hopefully we get some video. I don't know if we will or not. But.
And we just
Nominal
had...
orbit insertion.
That's what we were waiting for.
Stage 1, landing burn startup.
Landing burn startup.
So we got SECO 1 on second stage. We got a confirmation of good orbit, and the landing burn has begun on first stage. And now we have a live view of first stage making its way.
There it is.
Of course, I Still Love You.
Stage 1, landing leg deploy.
And we had some incredible views. Now we're just waiting for some confirmation of that first stage landing here in a second. As we have a live view of second stage currently with the engine cut off as it's coasting towards its targeted orbit. And we will wait for that confirmation of that first stage landing, but you have just witnessed Falcon 9's 26th flight for this year. And we will confirm once we have that confirmation for that first stage landing. So now at this time, our mission isn't over just yet. The second stage is now embarking on its first coast phase. Coasting in this orbit will last about 20 minutes, and we will light that MVAC engine for a second time shortly after T plus 28 minutes and 38 seconds. So we'll see you back here at T plus 28 minutes.
All right. Well, we will hang out for a bit and chat about space. I'm basically gonna continue my coverage for quite a while here. Make sure to cover at least until spacecraft separation, and if there's anything else to talk about after that, probably further as well. Hearing confirmations that the landing was successful. I'm not surprised by that. It looked very good before the video cut off. Oh yeah, I mean, SpaceX is just miles ahead in terms of recovery technology. The sad fact is that most other it caught the whole industry with their pants down, basically. Nobody else really was considering doing it in any serious way. It looks like the next successful recovery of a vehicle without dunking it in the ocean is probably going to be Rocket Lab. Rocket Lab has recovered Electron a couple times now, maybe 3 times, after splashdown, and it's in pretty good shape. They just announced Rocket Lab's next launch with Electron that tests reusability. They will be recovering the rocket with the helicopter. So the way that because Electron is a much smaller launch vehicle, it can't land like Falcon 9 does. Falcon 9 is able to do what it does because it's quite a large rocket. It has a lot of extra fuel left over, or it can have a lot of extra fuel left over. So it can do propulsive landing. Electron cannot do propulsive landing. It is too small. But because it's much smaller, it also is easier to recover in other ways. So it will be coming back through the atmosphere and then parachuting down. And then a helicopter will basically grab its parachute and then fly it to a ship where they will lower it onto the ship. And it will be transported safely back to the factory. So that whole thing is coming up pretty soon, but they're basically going to be the second company to recover a rocket, and I understand that changing the momentum of an entire industry is difficult, but we're getting to the point now where the big players in the industry, the launch industry, will probably just be recovering their first vehicles when Starship is regularly flying, and it's just SpaceX is kind of lapping their competitors right now in that respect. Da, 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 da. Kind of a cool little thing to note. So NASA put this mission out to bid, this Double Asteroid Redirect mission, as a ride share. It was originally just going to be on a rideshare mission. It would ride along with some other mission and sort of make its way out to the asteroid as soon as it could. It was planning to launch into geostationary orbit and then basically slowly work its way out to the asteroid. Sorry, big yawn there. But SpaceX bid had such a low or such an inexpensive bid, and SpaceX just bid a full Falcon 9 with no rideshare. They were just like, hey, you know, we can do the cheapest and we can also give it a full launch vehicle just for itself. We'll launch it way the heck out there as fast as we can, give it a big boost, it'll get there faster. So that's pretty cool. It was the cheapest ride, and it was also the most powerful ride. Was able to give the spacecraft a really good head start on its mission to the asteroid. So that was pretty neat. Kind of similar tales all over the place here. In a couple weeks, SpaceX is launching another NASA science mission called IXPE. So the IXPE spacecraft, I'm trying to remember what the acronym is. IXPE is the Imaging X-ray Polarimetry Explorer. And it's pretty cool. It's like it's an observatory for studying exotic astronomical objects. It has 3 telescopes. It's pretty neat. But the thing that really kind of blew my mind about it was they designed the spacecraft to fit in a specific rocket. When that rocket was the... Oh my god, come on, words. What is the name of the rocket? Pegasus. Jeez, took me a moment. The Pegasus rocket. Pegasus is an air-launched rocket. It's an old air-launched rocket. It's quite expensive for its size. And simply put, the spacecraft was designed to fly in Pegasus. However, when it came time to bid for the launch, SpaceX won the bid by bidding lower than the Pegasus rocket. Pegasus was going to be, I think, about $55 to $60 million, and SpaceX won it with a bid of $50 million for a rocket that is probably 20 times the size, and can give IXPE a much easier ride to orbit. So that's launching next month, and it's just cool seeing all of these missions get a bit of a break on price and a little bit extra performance. This is also kind of an interesting launch here with DART, because SpaceX has done a lot of launches now, but most of their launches have either been Starlink or for commercial customers in Earth orbit. They haven't done a lot of interplanetary missions because it takes a while before NASA entrusts their interplanetary spacecraft to a new launch provider, because they want to be really sure that they can do the job. So DART sort of is, it's going to be one of the first ones, but SpaceX has a whole laundry list of upcoming NASA science missions that it's launching. It's pretty cool. There's a really, really big ones coming up next year. Whole bunch of Falcon Heavy launches next year. Falcon Heavy is launching the Psyche mission, which is a really neat long-term mission to go visit the asteroid, called Psyche. The asteroid's name is 16 Psyche, and yeah, so Falcon Heavy is launching that sucker next August of 2022. Be really neat to see another Falcon Heavy launch. There hasn't been one in a while, although there probably will be at least one before that. There are a bunch next year. And also it'll be another interplanetary launch for SpaceX. Pretty neat. Currently listed, Falcon Heavy is supposed to fly here's what happened, right? COVID caused delays for a lot of things, and some of those things are U.S. Space Force satellites. SpaceX ran into a couple of payload delays, which really pushed out the timelines for Falcon Heavy. It was supposed to launch a few times this year. It didn't happen. Not a few times, I should say. Twice this year, but it didn't happen. The current schedule calls for SpaceX launching U.S. Space Force 44 in the first quarter of 2022. And then launching U.S. Space Force 52 in the second quarter of 2022. Also potentially in the first quarter of 2022, Falcon Heavy is launching Viasat 3, which is a commercial communication satellite. That launch will also have a spacecraft called Arcturus aboard it. And then next August is the Psyche launch that we were talking about before. And then also next year, in the third quarter of next year, a U.S. Space Force 67 satellite is also planned to launch. So as you can see, there's a whole bunch of activity for Falcon Heavy, next year. So that's really good. We'll actually get to see it get some more activity. Excuse me. Coming up on a few minutes here, we'll see second engine start 2. Oh my God. I'm going to show you something here. Let's see if I can bring it up. Da-da-da. Trevor Mallman with an amazing picture from the launch tonight. Trevor Mallman is excellent launch photographer. So let's just we're going to quickly hide the live stream. We're going to bring up image display. Here's Trevor Mallman's shot from the launch this evening. Beautiful, eh? What a great picture. All right. Go back to the live stream. There we are. right, we're just a couple minutes away here from resuming our coverage of the launch of the Double Asteroid Redirection Test. SpaceX themselves have now confirmed that the Falcon 9 first stage landed successfully on Of Course I Still Love You. Pretty awesome. All right. Should be about 2 minutes away here. I'm just checking for more updates on the mission. All right. So I think one of the interesting things about this mission is going to be whether... I sort of talked a little bit about this earlier, but I really do think one of the interesting bits about this, given our recent experiences at asteroids, is going to be trying to figure out, or not even trying to figure out, is going to be seeing whether the asteroid that they're hitting, known as Dimorphos is the small asteroid of the twin system, because it's a large asteroid with a little one rotating around it. Basically, it's going to be interesting to see if Dimorphos is a solid body or whether it's just a rubble pile. If it's just a rubble pile, well, DART's going to hit it at 24,000 kilometers per hour. If it's just a rubble pile, it's going to make a real big mess of that little asteroid. So I cannot wait for the pictures and everything. We don't have to wait a super long time for this mission. It's going to be 11 months, so next October we should see the impact. And hey, there's the Falcon 9 on the drone ship. Excellent. Look at that.
Welcome back to the webcast of the Falcon 9 mission carrying the DART spacecraft for NASA, and coming back with some great news, as you can see on your screen, that we didn't get a live view of touchdown. We do confirm a successful stage 1 landing today. That is the third for this booster, the 25th landing for SpaceX this year, and SpaceX's 88th overall successful recovery of a first stage. The second stage completed its first burn, placing the Falcon 9 and the DART spacecraft in the desired orbit. And right now we are approaching the second engine burn, the burn of the second engine to carry Falcon 9.
Back ignition.
All right, second stage has lit up for the second time.
And there's that SES-2, as you can see live on your screen, lighting up there. Now, this burn is planned to last a little less than 1 minute.
A little sparky there.
And during that time, we will add about 3.5 kilometers per second to our velocity. Now you can see the gauge on the screen showing stage 2 quickly gaining speed. We'll add about 3.5 kilometers per second, or about 12,500 kilometers per hour to our velocity. Again, this burn is the second burn for this mission. And cutoff should be coming up here shortly.
So they've now got that spacecraft up to, wow, 39,765 kilometers per hour.
Shutdown.
She's cooking.
We heard that call out that MVAC has shut down. Now just waiting for confirmation of good orbit.
Nominal escape burn.
Nominal escape burn.
And
that's
there
what you love
is that
to hear.
confirmation of a nominal escape burn.
Called out nominal escape burn. What that means, the Falcon 9 second stage, with DART still attached, has escaped Earth's velocity. It's now in what's called a heliocentric orbit. It's circling the sun in an orbit that takes it from just inside the Earth's orbit to just outside, where in 10 months, the DART spacecraft and those 2 asteroids should arrive at the same time. Now, the DART spacecraft is still attached to Falcon 9's second stage, so we've got one more major activity remaining in the launch mission, and that is spacecraft deployment. It's timed to occur at about T plus 55 minutes and 42 seconds. So we're going to take another short break, and we'll see you back here at T plus 55 minutes for the DART spacecraft deployment.
So we have another 25 minutes here. And I'm going to stick around for that. I want to watch the spacecraft deployment for sure. I might even stick around a little bit on the NASA feed and check out what they have to say about the deployment of the spacecraft and maybe the solar arrays. As there tends to be more content on that feed, I'm going to switch over to the NASA feed now. So just give me a moment here. Bit of good news. Next year, we should see, from what I've heard, next year we should see NASA move to higher quality streaming. That's what I've heard. So that's pretty cool in terms of like video quality.
Orbit, we're designing a new set of targets for the launch vehicle to hit on every single day, up to 90 targets in this case. So a fair bit of trajectory analysis, a lot of computer time, and a lot of work by the combined team, both here at NASA LSP and our spacecraft partners at JPL and APL, and of course, SpaceX.
Why the instantaneous window and not the longer window we typically see for scientific missions?
When we talk about launch opportunity, that is actually like the number of days that we can launch. And when we talk about launch window, that is the amount of time on a particular day that we can launch. So given the fact that we had 90 days to potentially launch this mission, and the fact that SpaceX has a pretty good history of launching on the first or second day in the opportunity, we decided that it was more efficient and a better use of the limited resources that we all have to do these kinds of missions, to focus on having the best launch trajectory for each day. And if for whatever reason we weren't able to launch that day, we've got another day right behind it.
And why did you guys ultimately decide to launch from the central coast of California and not here in Florida?
Great question. Typically, for a lot of our interplanetary missions, the most important thing is to get as much energy out of the launch vehicle, and that's no different for DART. However, usually the best way to do that is to launch as close to the equator and on an easterly trajectory. So Kennedy Space Center or Cape Canaveral Space Force Station are the ideal locations for that. As it turns out, though, this particular outbound trajectory requires that outbound ground track to be more in a north-south direction. And so we're going to launch from the west coast of California and fly out on basically a southerly trajectory. And that is a much better way to launch to avoid overflights of populated land masses.
Yeah, absolutely. And where will you be and what will you be doing during the launch?
So I'll actually be here at Kennedy Space Center. Typically, pre-COVID, in my role, I would be traveling out to the West Coast. I'll be monitoring the progress of the vehicle during Ascent and making regular updates to the NASA chief engineer, and right up to spacecraft separation, and then I'll be looking at the data from the rocket and making a determination of how well we did. And I'm very confident that we're going to hit that orbit very accurately.
Bill, it sounds like you'll be very busy during launch. I hope you find some time to enjoy what you guys have worked so hard to do. Thank you so much.
Thank you.
All right, thank you, Megan and Bill. Planetary defense takes planetary participation. Here's a message now from Administrator Bill Nelson about NASA's leadership in this global effort.
At NASA, we are always looking upward, keeping an eye on the sky for potential hazards and exploring asteroids to help us unlock the secrets of the formation of not only our solar system, but the universe. Well, we have a new mission. NASA's Double Asteroid Redirection Test. It's known as DART, and it's going to help us learn if by intentionally crashing a spacecraft into an asteroid to see if there's any slight change in its trajectory. And this collision will change the asteroid ever so slightly so that if you got it way, way away from Earth, if it was inbound to Earth, you could change that trajectory and it would escape Earth. And what DART's going to do, it's going to ram this asteroid, that is an asteroid revolving around another asteroid, it's going to ram it at 15,000 miles an hour and see if we can change that trajectory just a little bit. And DART is not only going to help NASA, but indeed the world prepare in the event that an Earth-threatening asteroid were to be discovered and we thought it was coming to Earth. So this is important. Go DART.
Go DART.
Thank you, Administrator Nelson. Joining us now is the director of NASA's Science Mission Directorate's Planetary Science Division. Let's welcome Lori Glaze to the NASA hangar, who just came from the Mission Control Center.
I like the
Watched the whole launch. You
like
get to
the
see all the
set.
cameras and the computers and everything. So first of all, I want to ask you, how was that?
It was really incredible, I have to say. Sitting there in the room with the headphones on, and you can listen to the spacecraft team as they go through all of their checks and making sure that they've got everything ready to go, and all the go for fuel, and then watching the monitors. You can see the fuel tanks filling up on both of the main booster and on the second stage.
Hey, Lord Kelmar. Thanks for joining. Yeah, I think it really does. Qualify as NASA's first pew pew. Yeah, I mean, it's not very efficient. They're basically just smacking into something as hard as they can. But yeah.
You're my boss, and I get to ask you questions. Well, and as part of your division, Planetary Defense Coordination Office is in there, and you've got the DART mission. What other missions are under the Planetary Defense portfolio?
So, great question. In addition to the DART mission, which we now have just launched, we actually also have a mission. I know you've been talking about the importance of detecting and characterizing asteroids. We have a mission that's called the NEO-WISE mission, or the Near Earth Object WISE mission, which is a repurposing of the old WISE mission that we actually use to do some detection of asteroids, but also a lot of characterization so that we know what the asteroids look like, what they're made of, and what their orbits are. And then we have a new mission that we've just started developing that we're hoping to launch in the next few years. That's called the Near Earth Object Surveyor mission, or NEO Surveyor. And that mission is going to be really dedicated to looking for those near-Earth objects. That'll be its sole purpose. We're going to send it out to a stable orbit called the Lagrangian point, L1. Should be an amazing mission.
We'll have the eyes in space besides just the telescope, which is pretty neat.
Exactly.
I got to wondering, with this kinetic impactor, we're testing that. We'll find out about that in about 10 months. But do we have it?
Yeah, I just want to clarify. We're actually looking at more like 10 months for the mission. They now have they have a date for the collision. They're expecting DART will impact the asteroid on September 26th of 2022. And I'll be here to live stream if there's anything to live stream.
The object by either adding or subtracting, and then you have changing the gravitational pull. Another idea which is out there is to potentially detonate a nuclear device, not on the, you don't want to blow up the asteroid.
Oh, well, it sounds like Armageddon.
No,
not quite.
No, you don't want to do that. You want to detonate it near the asteroid to just give it a push.
How about that? Fascinating. All technologies you're working on. Lori Glaze, Director of NASA Science Mission Directorate's Planetary Science Division, thank you for being here.
It's my pleasure.
All right, so with that, it's time to ask the expert scientists at NASA another question about the asteroids. And this one, folks, this one's for NASA asteroid expert Davide Farnocchia. We're going to ask him the question, is NASA aware of any Earth-threatening asteroids?
No, there is no asteroid that we know of that is concerning in terms of impact hazard. Now, we know that asteroid impacts have happened in the past and can certainly happen in the future. But we should keep in mind that those are rare events. An asteroid impact that could cause serious regional damage only happens every few thousand years or longer. Still, it's a good idea to protect us against that possibility, and the rule of the game is find asteroids before they find us. And that's why, for over 20 years, NASA has been funding search programs to observe the sky pretty much every single night to find and track asteroids. And we've been doing a pretty good job at that. So far, we've discovered more than 1 million asteroids, including 95% of the asteroids that are greater than 1
That's
kilometer.
a lot of freaking
and that
asteroids.
could come close to the Earth. Once we discover an asteroid, we project its motion into the future to assess the possibility of an impact with Earth. We have a scale called Torino scale that helps us rank the risk coming from each asteroid. It goes from 0, which is lowest risk, to 10, which is highest risk. The good news is that for all the asteroids that we've discovered so far, the Torino scale is 0, so lowest risk for the next 100 years. So, is NASA aware of any Earth-threatening asteroids? No, but we will keep searching the skies just in case.
And that's good news. We now heard about the instrument on board a little further back, the Draco camera. Now let's discuss.
It's worth noting, even though they've seen all those asteroids, there's a lot. Their best estimate is that there's a lot they still haven't found. So yeah, they do need to keep looking.
Hey Daryl, joining me right now is Smart Nav lead Michelle Chen. Michelle, give us some insights into what you call the brains of the spacecraft. How will Smart Nav allow DART to identify its
Lord Kelmar, they are not going to detonate a nuke in this mission. They are just suggesting other possible ways of deflecting an asteroid would be to detonate a nuclear device in proximity to an asteroid to push it. They're not doing that on this mission. This mission is a simple impactor, so they're basically using the spacecraft to just smack right into the asteroid and see how much they can move it.
Because everyone's been talking about the 15,000 miles per hour, so that's 250 miles in 1 minute. Wow. And for us to joystick that from the ground with the 1 minute round trip light delay for communications, it would be impossible. So we needed something autonomous on board.
That's incredible. So how are you feeling right now, and how are you going to feel, when we approach those 4 hours before impact?
Right. Yeah, so APL has a lot of experience on maturing guiding technology, and SmartNav is an IRAD that we started 8 years ago. And it's kind of like a child, right? So we've spent the past 8 years training and teaching this child to basically drive the spacecraft on its own. And like a parent would say, we're going to be sitting in the passenger seat, watching our child drive, and we're going to be really excited and nervous as all heck.
Well, we are rooting for your kid to do really well when the time comes.
Thank you.
Awesome. Thanks, Michelle. Back to you, Daryl.
All right, thank you both. And we have a fun way now, a little separation from the serious science, for you to participate in our mission today. And it's by signing up to be a planetary defender, just like Kelly. Here's a look at some of the people who sent us videos on how they got involved.
I'm a planetary defender. I love space.
Aww.
And my dog is also a planetary defender.
I am a planetary defender.
My dog is also a planetary defender. That's awesome.
I'm a planetary defender. Ascent planetari existit.
Jo soc defensor planetari.
That's cool.
Cosmo e io siamo difensori planetari.
Cosmo and I are Planetary Defenders.
We're Planetary Defenders! I'm a Planetary Defender.
Planetary Defender. Awesome.
Love the kid with the rocket engines.
That was great.
Yeah. If you would like to participate in being a Planetary Defender, there's a website. We're going to put it up on the screen. It's at dart.jhupapl.edu/planetary-defender. Again, that's dart.jhupapl.edu/planetary-defender. And there's a 5-question quiz. And then if you do well, you'll receive a digital certificate so you can share it on social media or, hang it on your wall. So guess what? Daryl and Kelly took the quiz.
We did.
And we have our certificates. Look at that.
Those are very shiny certificates.
Oh, yeah.
They use
I am
expensive
officially
paper
declared
for
a
those.
Planetary Defender on NASA's Double Asteroid Redirection Test.
I am proud of you, Daryl.
Thank you, Kelly. That means a lot. So, you took the quiz, right? And you passed.
Thank
I'm glad to
goodness.
hear.
That was kind of funny because I started working my way through the quiz, and I knew what the answer to the question was, but I wanted to make sure that I knew what they thought the answer to the question was, so I clicked on a hint, and a video of me popped up. So, and by the way, our Planetary Defense Officer, Lindley Johnson, he also took it and he passed.
That
Thank
is great to
goodness.
hear. That is great to hear. I feel like I needed a hint. Oh, there's me. Telling me what's up. All right. Thank you so much. Well, we have DART is scheduled to make an impact with its target asteroid in the fall of 2022.
So,
after that happens, scientists and astronomers around the world will work to verify if the redirection tests work. Let's go back out to Raquel Villanueva for more.
Just wanted to let everybody know that Canberra Observatory in Australia, as part of the Deep Space Network, will be involved in the acquisition of signal after DART deploys.
First thing will be the Draco images that are streaming back 1 per second. And this is the first time we get to see what this asteroid looks like. And so I guarantee the team at APL is going to have these images up on the big screen, seeing what the shape is, seeing what the geology is, seeing where we actually hit.
So cool.
But then there's more. There's LichioCube, and those images are actually going to take a few days or weeks to come back, and they're going to show us the ejecta from the collision. And the telescopes are going to get right to work too here on the Earth. They're going to be turning their gaze and trying to figure out how much we actually deflected this asteroid. And that's going to go on for months. And then we've got a bunch of people with state-of-the-art models who are going to model the impact, model the ejecta, model the dynamics, and they're going to use the inputs from the images and the observations and all come together. It's going to be a really, really busy time.
Sounds like it. And can you tell me why the impact, the timing of the impact is important?
Yeah, it's really interesting because September 2022 is the perfect time to do this. So Didymos and the Earth, they both go around the sun, right? But it actually takes about a little over 2 years for Didymos. So sometimes the Earth and Didymos are on like the opposite sides of the sun and really far away from each other. But in September 2022, it's actually minimized. They're going to be the closest that they are for 40 years. And that's going to let the telescopes here on the Earth get the best data possible of how much we deflected this asteroid.
Wow. And scientists around the world, will they be able to confirm your results?
Yeah, I'm actually super happy we've got scientists around the world on the DART team. And so this is an international team for an international issue, right? Like planetary defense is our whole planet. We're all on it together. And that's there. We've got obviously the LichioCube contributed by the Italian Space Agency. We're also really working closely with the European Space Agency's Hera mission, which is going to rendezvous with the Didymos system in 2026. And it's going to be able to see the crater, get the mass. And it's really exciting because, DART is just the start, and then Hera will get there, and these two missions combined will show us even more than anyone could do on their own. And it's just really a great example of international collaboration for this international issue.
It really is. And what was it like seeing the launch today?
It was really spectacular. I didn't really know what to expect so much, but then when you just saw it like light up through the sky and sort of change the things, and everybody erupts in the cheers, It's really real, you know, and but in some ways this is just getting DART onto this next phase. I'm looking forward to these 10 months and then the collision and then everything I just described starts, and we've got so much to look forward to.
Busy time ahead. Thank you so much for joining us, Nancy.
Thank you. This is great.
Back to you, Daryl.
All right, and as she mentioned, when DART impacts the asteroid, the spacecraft and the onboard camera will be completely destroyed. But we will see DART's last maneuver thanks to an Italian CubeSat that will jettison from DART 10 days before impact. For more on this, we are joined by Simone Parata of the Italian Space Agency. And we're going to talk about LICE-CUBE, which stands for Light Italian CubeSat for Imaging Asteroids. So how did this idea for a DART CubeSat actually come about?
Thank you. So the idea of CubeSat came about in the time frame of 2017. At the time, the Italian Space Agency was already running a project that is called Argo Moon, and it's a similar CubeSat that will fly on the Artemis 1 mission. So this CubeSat will provide important information and images of the launcher. So we thought, why don't we propose a similar CubeSat that will support the DART mission? Anyway, we were somehow, contacted by NASA, and then the idea came in this way, and we started this new challenging project, and we are very excited to be here.
Yeah, it's like DART throwing out a cell phone to take a selfie right before it rams into an asteroid.
Right.
Yeah, I don't know if it's okay. We still kind of sometimes refer to it as a selfie sat, but or seriously, what can you tell us more about LICE-CUBE's scientific objectives?
All right. We will support DART. We are kind of witness of the immediate effect of the impact, because later on, the effect of the impact, yes, will be measured from the Earth by telescopes, but we will provide unique images. Yeah, this is LICE-CUBE. It's has been just deployed from DART. So while DART is targeting and then impacting the asteroids, we will maneuver in a way that will allow us to pass in a safe distance, so not to be impacted by ejectors, but at the proper distance to have a good resolution of our images.
That is super cool.
Yeah, so the plumes is important information,
cool.
And we will also provide information on the other side of the asteroid that is not visible by DART.
Hey, Lord Kelmar. So that's actually a really good question about DART's size and mass and payload. I don't think it has like I don't think it has like an actual core that is intended to make the impact worse or anything like that. Its mass is it's expected to have a mass of about 500 kilograms at the time of impact. So it's decently big. It's about half a ton. But yeah, my understanding is that it's that mass is just the mass of the spacecraft, and that it doesn't actually have a proper hammerhead impactor on the front of it or anything like that. It's kind of interesting because we've seen that in the past. Japan did an impact with an actual proper impactor, but I think in this case they basically just decided that it wasn't really required. If you were gonna see a mission where we were actually trying to redirect an asteroid that was a threat to Earth, it would not surprise me at all to see that one with a much more significant, purpose-built design to be an impactor that could deflect and impart more of its momentum. But yeah, that's what I know about it.
Good information on also on the morphology of the surface, maybe the crater. The crater is not completely sure that we can image because the plume can cover it. We can when we need the proper time to allow the plume to be developed enough. So while we are having our flyby, we can have a complete modeling of how the materials will be released.
That's fantastic. Simone Parada from the Italian Space Agency. Thank you so much for that. Thank you for bringing your Legos.
Yeah.
That was great.
It is like a kind of lucky charm for us, and my daughter wants this back, so I'll take it back to Italy.
All right, let's check in with Marie and Denton to find out more about spacecraft separation, guys.
All right, thanks, Daryl and Kelly. It was a very interesting conversation. We are about 45 seconds or so from spacecraft separation when the Falcon 9 second stage and DART will be over the Indian Ocean near Madagascar. And then the job of the Falcon 9 rocket will be officially complete for this mission.
Yeah, absolutely. I mean, the job of Falcon 9 was to get DART on its way to the Didymos system. At this point, we've gotten enough velocity, enough speed to send DART off towards the Didymos system. And right now, we're in range of the ground station, so we can get all the data from, and so we can make sure we can actually capture the separation confirmed. And we
DART
just heard the
separation
call up
confirmed.
for spacecraft separation.
There she
You can see
goes.
this video
Awesome.
of the
DART
spacecraft on its way, heading
you
on
can see
its
the
way
Rosa
to the
solar
Didymos
rays
system.
there on
What
the
a
sides.
spectacular view.
That's amazing.
Of DART.
Yep.
That is
just
amazing.
floating away from the Falcon 9 second stage.
And you can see the sun off to the side there as DART drifts away from the Falcon 9 second stage.
And so this officially begins almost a year of cruise for the DART spacecraft, flying through on its way to the Didymos system. And at the time that it impacts Dimorphos in late September 2022 is what we expect, the Didymos system will be within 11 million kilometers of Earth. Again, to remind folks, this system does not pose any kind of threat to Earth. This is purely a test. And so DART, when it approaches, will smash into Dimorphos, the small moonlet of Didymos, at 15,000 miles per hour. Just astonishing rate of speed.
Yeah, absolutely.
Now, the next thing that we have to get through, obviously, spacecraft separation is a huge milestone, but we're not out of the woods yet. We still have to get acquisition of signal from the DART spacecraft, and that takes a little bit more time, right, Denton?
Yeah, and at this point, the launch vehicle has done its job, and we just want to make sure we basically hear from the DART spacecraft to make sure it's doing well. And if you think about it, it's kind of like getting off of a roller coaster, right? You know, you step off the roller coaster, you know, you kind of steady yourself. You want to check your pockets, make sure you didn't lose anything along the way, make sure you're okay. And that's basically what we're looking for from the DART spacecraft once it gets that acquisition of signal, because it's going to kind of go through its self-checks, make sure everything's okay, and then it's going to send word back to home, basically saying, hey, I'm doing all right. And that's what we're looking for right now. And that's, I mean, because if we don't get that, then it's kind of all for nothing, right? You want to make sure that the spacecraft is doing well after it's gone, separated away from the launch vehicle.
And you've got ground stations all over the planet that are looking for this signal from DART, and we'll be trying to start picking that up very soon.
Right, and then sometimes it's not an exact, it's not exact, because sometimes the timing may vary once you get in range of certain ground stations. There could be weather kind of impacting that signal strength, etc. So there are various factors that come into play. So, but we're expecting to get it coming up in a few minutes, but hopefully we'll get that so we can get good word that DART is doing well.
Okay, and so there's a range that we're expecting. Acquisition of signal could be as early as around T plus an hour and 7 minutes, so that's 9 or so minutes from now. It could be as late as T plus 1 hour 34 minutes. Like you said, it's not an exact science. We'll know when it happens. We'll give confirmation as soon as we hear it. But for now, we're going to keep an ear on things. And Daryl and Kelly, we will send it back to you.
All right, Marie and Denton, thank you so much. What beautiful imagery seeing that DART spacecraft sailing off. Well, DART will be destroyed after it smashes into its target asteroid. But years from now, a new spacecraft will follow DART's path to
Hera.
the same double asteroid. Joining us now is Ian Carnelli, the European Space Agency's project manager for Hera. Thanks for being here.
Thank you for inviting me.
Well, tell me a little bit about what Hera does and how it got its name.
All right, so Hera will be launched in October 2024. So a few years out. It's currently now in integration. And we'll launch it from Kourou and arrive at Didymos in 2026, around Christmas Day. And our primary purpose is really to complete the investigation, to understand what has happened during and after the DART impact, so understand the dynamics, the geology, what the asteroid is made of. And the name is quite funny. Actually, we had an evening with the scientists, and we were thinking about names, and I only had a constraint from my boss saying we don't want acronyms for once. So the idea...
Yeah, and so it was a perfect choice, but it's because there are two aspects of this, right? What is this?
Exactly. So these are the CubeSats. So here we'll bring with it two CubeSats, one called Milani, after actually the scientists who brought up the name of the mission
that's neat.
and the concept,
Look at that.
and Juventus. So the two CubeSats will perform scientific investigations. Here we're seeing the booms deploying from Juventus. That's actually a low-frequency radar. What it does is actually like a X-ray. We'll want to understand what is the internal structure
that's actually
of
gonna
the
win.
asteroid, to understand if there are voids or if it's a monolithic rock.
How about that?
Yeah, so imagine...
Literally going into the crater that DART created?
Exactly, that's the purpose. And so Hera comes after the goddess, the Greek goddess of marriage. And the idea being that despite being hit by DART, the two asteroids will stay together. So that was kind of the history behind the name.
I love it.
Well, yeah, and we just got DART off the planet. And so why is it important now to, a few years later, for Hera to go and then follow up?
Yeah, absolutely. So we are so excited about DART. It was an awesome launch. And we're all expecting beautiful science data to come next year. But then the purpose of Hera is really to complete the experiment, to get close and personal, and get all of the science data that we need to actually calibrate our numerical impact codes, meaning that we can reproduce on our computer simulations exactly what happened during the DART impact. And that will allow us in the future to be able to design a planetary defense mission if we need to on another object. So we will have all of the models calibrated so that we can use it on another asteroid.
All right, Ian Cornelli, fascinating stuff, and a great mission to follow up on this DART mission. Appreciate you being here.
Thank you for inviting me.
All right. Well, now we are getting to the big moment where we're going to try to acquire a signal from the DART spacecraft. And so let's take a look inside at the Mission Operations Center and the Johns Hopkins
It's looking like we might have
University's
acquisition
Applied
of signal
Physics
already.
Laboratory. If we have that, that's where the real work is going to start being done in terms of acquiring that signal.
Seeing some
And in
tweets
just a few
from,
minutes, we're expecting that DART team
ESA
to do
operations.
just that, acquire the signal. But as Marie and Denton mentioned, it's not an exact science. You know, we got to go through some stations to make sure we acquire that signal and get it in there. But you're pretty familiar, Kelly, with the people who are going to be in that room waiting for the signal to come in.
Well, the Planetary Defense Coordination Office and the Planetary Science Division have been working with the Applied Physics Lab and with the co-investigators at other institutions for a long time on this. And yes, it's a mission, it's a task. People have their jobs that they need to do, but I mean, these are individuals who are really passionate about what they're doing, and so they're really taking this to heart. And I'm sure they're still on pins and needles as they work their way through this part of the mission.
Speaking of pins and needles, there we see the room there, as you can see at the lower bottom of your screen, awaiting DART acquisition of signal, and that area right there is called the command pit at APL, and so those folks are patiently and intently listening for communication from DART to the ground. So while we await that, let's send it over to Marie and Denton, who are monitoring the launch team communications as we await acquisition of signal.
So right now, Daryl and Kelly, it's just a lot of waiting and listening. There's almost no chatter going on the loops. Everyone is just kind of waiting with bated breath. At this point, we're at T plus 1 hour, 4 minutes and counting. And just in it all kind of comes down to these final minutes. When are we going to get that signal? Yeah. Years of work. Some of the people in this room, probably, if not all of them, have poured years of their life. This is their life's work into this mission. And so what's it like waiting for this confirmation?
Yeah, and so, having been on the launch vehicle side and sitting on console and working this, what, you've been working years to kind of get to this point. And as you mentioned, the spacecraft team has been dedicate most of their careers or their life's work to the spacecraft. So, getting through the launch, he's like, great, we had a great launch, everything went successful, but you want to make sure you get that confirmation from the spacecraft. So it's a little excitement that we got through the launch, but it's a little nervousness as we okay, we want to make sure the spacecraft is doing okay. And so it's a mixture of excitement and nervousness at the same time.
Yeah, and you mentioned nervousness, and we see some clapping. We haven't heard anything, so trying to see if we can find out if
So we waiting to get positive confirmation that we've actually have got signal from the DART spacecraft. So we're just waiting to get word.
Well, I can do it for them. They've acquired the signal. ESA's acquired the signal.
If you're just joining us, this is a live view of the Mission Operations Center at Johns Hopkins Applied Physics Laboratory in Laurel, Maryland. This is where the spacecraft team is waiting to receive confirmation of acquisition of signal from the DART spacecraft, currently on its way to the Didymos asteroid system.
So,
where we expect it will
DART
impact
has
the moonlit
begun
Dimorphos
to detumble,
in late
which basically
September of
means
next
that
year.
it is basically stabilizing itself, and it is beginning to change its orientation to point at the sun for solar array deployment.
And Denton, while we wait to hear whether we have acquisition of signal, I was going to mention, the teams rehearse this many, many times. There are pages and pages of procedures that have to be followed down to the letter, and you go through everything a final time during the mission dress rehearsal. This team did that less than a week ago from the control rooms here in Vandenberg, at Johns Hopkins, all around the country. And this is the one thing that you can't really predict. You don't really know when it's going to happen.
Right. So it all comes down to different the environments and different variables that play out on launch day. And whether you're going to get that signal early or whether you're going to get it later, you won't know until you get up there. So, rehearsals and practice is great.
Little uncertain as to why they're talking about this. On Twitter anyway, the Canberra array in Australia says that they have picked up the signal.
When we think we could get acquisition of signal, so it could happen at any moment.
Right.
Maybe there's some specific signal they're
look
waiting
in the room,
for.
You can kind of see that nervous energy. People just waiting to get that confirmation of spacecraft, I would say, first signal from the spacecraft, and make sure that the spacecraft is doing well.
And then after that signal is acquired, there's even more to be done. That's a huge moment of celebration, sigh of relief, but there's still a lot of work to be done on the other side of that.
Absolutely. So that's when the DART team, the spacecraft team, that's when their work really begins. The launch vehicle team pretty much did all their work kind of leading up to spacecraft separation. Now it's time for the DART team to kind of really moving forward on the operational side of their mission. At this point, because they spent years developing the technology, building the spacecraft, and now, since we've had a successful launch, the operational side of their mission really begins.
Official acquisition of signal from the DART mission using the 4.5 meter array in New Norcia, Australia.
So we just got confirmation that we do have acquisition of signal, which is great news that the spacecraft is being able to talk to the team on the ground. So that's a good thing.
Yeah, huge news. It's a process from this point. The solar arrays on DART will still have to unfurl. That process does not begin until about T plus 1 hour and 42 minutes. So that's still quite a ways away. And
All right,
that
folks.
process will.
I am not going to stick around for the unfurling of the solar arrays, even though I kind of want to. It is getting late. I need to get some sleep. Thank you very much all for watching, and yeah, have a great night. Go DART, and I'll try and live stream again when DART arrives at Dimorphos, which is September 26, 2022. And I'll try and do a few more live streams coming up here before the end of the year for the upcoming missions. Have a good night.